Good morning, guys. Am I audible to all of you?
Good morning, sir.
Okay. So after a long time, we are going to resume our sessions, and hope the sessions are going to be continue. And I will try my best to complete the course as soon as possible. Right. So we have already started entity framework code first approach, and we have already discussed the how we can configure the model classes using data annotation, right? So by default, some code-based convention followed by entity framework. If you want to override the default convention, which is followed by entity framework, then we have two approaches. One is data annotation attribute, and the other approach is Fluent API configurations, right? We have already discussed the data annotation attributes. Today, we are going to discuss how we can configure the model classes using Fluent API, right? So like the data annotation attribute, the entity framework provides Fluent API, which we can also use to configure the domain classes. And once we configure the domain classes using Fluent API, then it will also override the default configurations or default conventions, which is followed by entity framework, right? The Fluent API is based on one design pattern, which is called as Fluent API design pattern, or you can also call that design pattern as Fluent Interface Design Pattern, right? Where, so what exactly this design pattern means is the result is formulated by method chaining, right? So what we need to understand. So before understanding the Fluent API configuration, how exactly the Fluent API configuration works in entity framework, we need to understand Fluent Interface Design Pattern. But to understand Fluent Interface Design Pattern, we need to understand one concept called method chaining, right? So what is our goal? So first, we will try to understand what exactly Fluent API Design Pattern is, how method chaining is used to implement Fluent Interface Design Pattern, and then we will understand exactly the Fluent API configuration and all these things, so that you can easily understand the things, right? So let us start a discussion by let us start understanding the concept Fluent Interface Design Part. So I already, if you remember, I have already given a brief, a small introduction to Fluent Interface Design Pattern. But today I will explain you exactly what exactly this Fluent Interface Design Pattern, how you can implement this, what is the advantages of implementing this, and then we will try to understand the Fluent API. The main objective of Fluent Interface Design Pattern is to apply multiple methods to an object by connecting them with dots, without having to re-specify the object name each time. For example, if I'm having a class called student, and if that class having 5 methods, forget about these properties, right? Whatever showing in this diagram, forget about these things, right? If I'm having a class, and if that class having 5 methods, let's assume 5 methods. And if I want to consume those 5 methods, then what is the process? The process is first I need to create an instance of that class, and then by using the instance and dot operator, I can call the method. And in this approach, while calling the method, each time I need to specify object name dot operator followed by the method name. This is the approach what generally we follow. But we don't want to follow that approach, right? So what exactly we want to follow? Now, instead of specifying the object name each and every time while calling the method, we need to specify the object name only once, and then by using the dot operator, we can call the method one after another. And that is nothing but your concept called method chain. How we can implement this? Let us try to understand. For example, let's assume that we are having this class, right? So student class, and you can see this student class having 5 properties, right? So this student class having 5 properties, that is registration name, DUP branch, and address. Now, if you want to set the values of these 5 properties, then what do you generally do? Generally, we need to create an instance of the student class, and then by using the student instance, right? By using the instance and dot operator, we can set the values of the respective properties like this. You can see this is my student class, and this is the initialization of the properties of the student class. Generally, this is the approach what we follow. Yes or no? guys?
Yes, sir.
Yes, so you have to create an instance, then you have to set the name, registration number, DOB, branch, and address like this. This is the approach what we generally follow. But now, what is Fluent Interface Design Pattern says, now it simplify our object consumption code by making our code more readable, simple, and understandable. Is not it nice to set the object properties as shown in the below image, right? So instead of student.name registration div branch address, if I'm creating something like this student object, I have created the object of the student class, then I'm saying student registration number. Here you can see registration number property and I'm setting like this, but now I'm creating a method student registration number, and to this method I'm passing the value. Then I'm not re-specifying the object name dot operator, but rather than I'm using the dot operator, I'm calling name of the student and passing the name. Dot born on, what is the date of birth that I'm passing here, what is his branch or what is your branch that I'm passing on the study on method, and where he stays, right? That is his address, I'm passing to this stage at method. That means what? Now I'm not going to specify the object name each and every time while setting the method or while calling the method. Rather than I'm using the object only once and then I'm calling the method one by one by using the dot operator. And this is nothing but your method chaining, right? This is fine. This is method chaining, or you can say this is nothing but your Fluent interface design part. The question is, it looks very simple and it makes a sentence, right? If you consume the object like this interface, then it is something like we are speaking a sentence, right? We are speaking a sentence. What sentence? Yes, please set the student registration number, name of the student is this, he is born on this, stay at this, and study on this. So this is nothing but a sentence. So if you compare these two, if you look at these two images, right, there is no difference technically. But this sentence, this approach will give you a sentence. But this approach will not give you a sentence because this is not a single sentence. You can see whenever you specify the semicolon, that statement is ended. But here we are not specifying the semicolon at the end of each method call. At the end only we are going to specify the semicolon. So that means it is a single sentence and it is a multi-statement sentence, right? So this is fine. But the question is how we can implement this. How we can implement this in the sense how we can create call on one method and how that method is going to set the name property. How how I can set the registration number value, how I can set the DOB branch address, everything. Our main objective is to initialize the object, but how we are going to initialize, not by using this approach but by using this approach. And how we can implement this, the answer is by using the concept called method chaining. So this is nothing but your Fluent interface design pattern. In this case, it will provide you an interface, and using that interface only by we are going to set the values of the respective properties. And to set the values of the respective properties, right, we are going to use the concept called method chaining. So what is method chaining and how we can implement this? Let us see. Method chaining is nothing but a technique where each method set the value of a property of an object and then returns an object, and all these methods can be chained together to form a single statement. What exactly it means? To understand this, so what he is saying, method chaining is nothing but a technique or a process where each method set the value of a property of an object. So in this case, this is the method chaining. So in this case, each method, right? In this case, you can see using the student object, I'm calling 5 methods. So each method is going to set the value of a property, right? So you can see in this case, student registration number method is going to set the REGD number property value. This born on whatever value I'm passing, that value will be stored inside the DOB property. What is study on? So this method I'm passing CSE. CSE means this value is going to be set on the branch property. So this is nothing but method chaining. Method chaining is nothing but a technique or a process, right? So, or you can write or a process where each method set the value of a property of an object. This is the first part. Once it is set the property value, right, then what it returns. Then if you remember, whenever we are creating a method, then we can create the method with return type and without return type. If without return type, then the return type is going to be void. But if with return type, then you have to specify the return type. The return type can be a primitive data type like integer, character, float, can be a reference data type, right, like employee, student, and anything, right? So in this case, and wherever this born on method available in a particular class, the study on method is also available in a particular class. This name of the student method is also available in a particular class. In which class these methods are available, that is going to be return type of these methods, right? Then returns an object returns, and all these methods can be chained together by using the dot operator to form a single statement, right? In order to achieve this, right, in order to implement this, what we need to do, we need to create a wrapper class around the student class, right? So wrapper class around the student class, you can see. So we have already this class, student class. So I'm going to create a wrapper around the student class. Wrapper class means it will wrap the object initialization logic. So what I have done, I have created one class called Fluent Student. Inside this Fluent Student, I have created an object of a student class. Then what I'm doing, I'm just creating the student registration number method. And this method takes registration number property, registration number as input value. And then it will set the registration number of the student. And then return this. Return this means current object. Current object means Fluent Student. So similarly, name of the student, set the name of the student and return the Fluent Student. Born on, also set the name of the student and return this one. So like this, if you see all these methods, they are setting a respective value, respective property value of the student object, and then return the current instance, right? Current instance means if I am specifying this, in this case, they are returning the Fluent Student instance, right? So this is how you need to implement, right? Once you implement this Fluent interface, right? So it is saying Fluent Interface Design Pattern, because the reason is here we are not going to interact the student object directly, rather than we are going to interact with the student interface, and that student interface is going to internally share the respective object values, right? So once you create this Fluent Student, now what you need to do is you need to create an instance of Fluent Student class, and then you need to call the student registration number, name of the student, born on, study on, stage at, and then while calling the method, you need to pass the value. And remember, this student registration number method return an object. And what kind of an object? Fluent Student. So any method which are available within this Fluent Student class, you can call directly. How? Like this. So you have to create an instance of a Fluent Student class. Then you need to call the student registration number method. What this student registration number method return? It return an instance of a Fluent Student. And then I'm able to call this name of the student method. Why? Because this name of the student method is available within this Fluent Student class. Then I can call this born on, stay, study on, stay at, and here the sequence doesn't matter. Any sequence you can call the method as long as the respective method is available on that returned object, right? So in this way, you can implement the Fluent Interface Design Pattern, right? Let me create one application. Right. Okay. Let me copy the code. Right. So you can see this is my student class. This is my interface class, Fluent Student. And here I'm creating an object of student class. You cannot access this property from directly outside the class because it is private, right? And these are the public properties. Public properties means by using the instance of this Fluent Student class, you can access. So you can see this is the registration number, name of the student, born on, study on, right? If you are getting confused why, what is this, you can also write like this. This is also high, right? Because in this case, this Fluent interface, nothing but this is the instance. And if you write this, then also it is going to be same, right? So in this way, you can implement the Fluent interface design pattern, and then you need to create an instance of a Fluent student, and then you need to call the method like this. Sequence doesn't matter, right? So you can call this method here, right here, stay at, you can call the stay at method before the, right? So sequence doesn't matter, right? So you can call the states at method here also. There is no issue, right? What is matter? Matter is what the method is returning. See, in this case, born on method returning some current object, right? So instead of, if I make this method as void, void means this return statement is not available here. So now once you call this born on method, what this method is returning? Void. Void means you cannot call the next method. You cannot call the next method. Why? Because this method written in void. On void, you cannot call a method. But if you change these things, right? If you change these things, immediately the error will be gone. Because in this case, a born on method returning an instance, right? And guys, remember, in this case, I'm able to call. Now, let's assume I am having one class called employee, right? I'm having one class called employee, and let me, what is the last study on, right? Right, class employee, let me give this as public, right? And let me, what is the method born on, where is born on? Yeah. So let me convert this to employee, and they let me write this one, right? So in this case, you can see born on method return type is employee, and then I'm calling this study on, and in this case, I'm getting the error. Why I'm getting this error? Can anybody tell me? Guys, why I'm getting this error? Clearly, it is saying employee does not contain a definition for study on. So in this case, born on method return type is employee. So it will check the study on method on the employee class. And in employee class, there is no method. And this is the reason why it is giving me the error. Now, if you remove study on method from here, right? If you place this method here, right? Then the error is going to be gone. The error is gone. So the point that you need to remember is, right? You can see now the error is gone. So the point that you need to remember is, so the point that you need to remember is it will always check the return type of the current method. And if you call the next method, then it will check whether the next method is available on the return object of the current method. In this case, if the student registration number method return an object, and in that object, if this method is available, then that is fine. If not available, then it will give you the error. This is the point, and this is how you need to implement the Fluent interface design patterns, right? Using the dot operator and using a single object, you can call the methods like this, right? Now, if you run the application, then you will not get any kind of error. Why I'm getting this error? Okay, employee could not be found, right? So here I'm writing employee, so you have to make this as Fluent employee, and this is right. So this is how you need to implement Fluent interface design patterns. Clear, guys? Right now,
Yes, sir.
you will not get any kind of a error, right? So this is the base to understand the Fluent API, right? If you understand how I'm able to call this student registration number on the same object, how I'm calling this name of the student, stays at, born on, study on, right? This is only because of the implementation of this method. This implementation return one object, and on that object, I'm able to call this method, right? Now, give me 1 minute, guys. Okay. So now I hope you understand what is Fluent Interface Design Pattern. Now we are going to discuss configuring Fluent API in Entity Framework, right? The point that you need to remember is that Fluent API can only be used when you are working with Entity Framework Code First approach, right? We have already discussed database first approach, right? In database first approach, you cannot use Fluent API. If you remember from while we are discussing the database first approach, at that time I have told you that there is a method called on model creating that I will discuss while while I'm going to discuss the entity framework code first approach. Why? Because this Fluent API is going to work only when you are working with entity framework code first approach, right? If you are working with the database first approach, then this is not going to be work, right? In entity framework, there is a class called the DB model builder class, which will act as a Fluent API, right? Which will act as a Fluent API. So if you say this example, in this example, this is Fluent student, right? This Fluent student class will act as a Fluent API, right? As this act as a Fluent API, using the instance, I can call the method by using the dot operator one after the another, right? In the same way, right? While you are working with Entity Framework, there is a class called the DB model builder, right? This DB model builder class act as a Fluent API using which we can configure many different things, right? And it provides more options than data annotation attribute. In this case, what we need to do? We need to override the on model creating method, right, of DB context class. And then we need to configure whatever you want to configure using the DB model builder, right? So how you are going to do this, the example is given below, right? So in this case, you can see this on model creating method, right? This method is available in the DB context class, right? If you go to the definition of a DB context class, this is my context class. If you go to the definition of a DB context class, there is a method called on model creating. What kind of a method is this? This is a virtual method. If it is a virtual method, then can I override that method on my class? Is virtual methods are overridable?
Yes.
Right?
Yes,
Right.
sir.
So you can see this is a virtual method, and this method is taking one class of a DB model builder. So by using this instance, you can configure a method chaining, right? How you are going to configure, you can see by using this model builder instance, I'm calling one method entity, I'm calling one method property, I'm calling one method has column name, has column order, has column type. And all these things is possible because this is a Fluent API. What is the use of entity property, has column order? All these things we are going to discuss. But for now, you just think that this is a method, all or whatever you are seen in this diagram, right? Everything it is going to be a method, and each method having some responsibility. And that responsibility means how the model is going to be configured, right? While generating the database, those information is provided to the entity framework by this model builder class, right? Now, if you expand this, what this method is saying, this method is called when the model for a derived context class has been initialized, but before the model has been locked down and used to initialize the context, right? So what exactly he's saying? Now he's saying before initializing your context class, this model is going to be executed, right? That model is going to be executed, right? So before initializing means whatever the data set you have, whatever the DB set, whatever the initializer you use, right? So before creating the instance, right? So before doing anything, before creating the database and before generating the database schema and everything, right? This method is going to be executed, and once this method is executed, then only it is going to update the database schema or generate the database schema in the database, right? So before generating the schema, this method is going to be executed on model creating, right? So this is how you are going to configure your model using entity framework code first approach using Fluent API. Everything we are going to discuss, what are the options, right? what are the things you can configure model wise, how you can configure the things entity wise, how you can configure the things property wise. Everything we are going to discuss one by one, right? Fluent API configuration, right? In entity framework, Fluent API configuration configure the model class in three different ways. We can configure model wise configuration, right? Configure the default schema, right? If you want to configure the default schema, if you want that whenever a database object is created in the database, the default schema should be ABC instead of a DBO. If you want to configure that thing, then you have to go with a model wide configuration. Yes, other options is, so once you configure the default schema, if you have 10 model classes, you want to create a 10 database table. You want 8 database table having the default schema, but you don't want that default schema for 2 different tables. That is also possible. You can also configure the schema at the entity level, right? So this is the model wide configuration. Entity configuration, you can configure the primary key, you can configure the foreign key, right? Foreign key means this relationship are going to be established using the foreign key. You can configure the index, you can configure the table name, right? Any entity level configurations, if you want, then you can also configure. Then property configuration, it is also possible to do property level configuration. Property level configuration means whether you want to make the column as null or not null, right? Whether you want to map a column or not, right? You want to set the foreign key is not available here, right? Yes, foreign key is also available. Data type of the column, what kind of if you want to set the data type, if you want to set the size of the column, right? If you want to maintain a particular column as concurrency column, if you want to set the order of the column, right? So all these things you can configure using the property configuration. So Fluent API configuration means we need to understand these three configurations. So let us try to understand what are the methods available in each configurations, and then we will see the real-time examples of using those things. So model-wide configuration, this model-wide configuration provide one method called has default schema. It configures the default database schema name. This default database schema name is used for database object that do not have an explicitly configured schema name. What it means if you want, as I told, if you are having 10 models in your class, in your application, and for those 10 models, you want to generate 10 database tables. Out of a 10 database table, you want 8 database table having the default schema as admin, right? Then you can configure as default schema for your entire entity as admin. Then that admin will be applicable to all the 10 different tables, right? But if you explicitly specify any database table schema, then that will have the highest priority over this default schema, right? So explicitly, you can also configure the schema. Default schema is also you can configure. Both options are available, and I will show you both the options practically. And this is model-wide configuration, entity-wise configuration. If you want to create any index, if you want to create any primary key, if you want to maintain many one-to-many relationship, if you want to make any property as nullable, if you want to make any property as not null, right? That means if you want to generate index, you have to use this one. If you want to make any key as the primary key, composite primary key option is also available, then in that case you want to implement has key. If you want to configure more than one relationship, right, multiple one to many or many to many relationship, then you have to use this one. Has optional means, if you remember, by default what happens now, any primitive data type they are going to be created as not null. Any reference data type they are going to be created as null column in the database. Any suppose you are having a primitive data type, you are having a integer property, but you want to make that property in the database as a nullable column, then you have to use this has optional method. If you remember, by default any string type property are going to be created as nullable column in the database, but you don't want to make that column as null type in the database, then you have to use this as required. It will make the column as not null, and once you make this as optional, it will make the column as null. right? Ignore. If you want to ignore any property while mapping the database, then you have to use ignore. It is not only used for property mapping, but also if you want to ignore a table while generating the database, right? If you don't want a class to be created as a database table, then you can also use this ignore table. Map method means what? It allows some advanced configurations. Advanced configuration in the sense what? Now suppose you are having a table, you are having a model class. That model class having 10 properties, right? Now you want 5 of the properties to be created as a one table, and another or the rest 5 of properties to be created as a different table in the database. That means one model class but two different tables. And if you want to implement that, then you have to use this map method. Map to storage procedure. If you want to map any kind of storage procedure to table, that means if you want to explicitly provide the table name, right, for a model class, then you have to use this two table. By default, if you know whatever the dpset property name, within the same property name, the database table is going to be created. But instead of that default naming convention, you want to provide a user defined name, you want to provide your own name, then in that case you need to use this two table method. Then these are the properties, right? Property configuration is required. It configures the property to be required. Means what? Now while entering the value, it is mandatory to enter the value. It's concurrency token, right? If you want to maintain the concurrency, right, while performing the update operation on the database, or while performing the delete operation on the database table, then in that case these two things are will come into the picture. We have already discussed each row version in database data annotation. The same row version is also available here, and each concurrency token, this is available. If you remember, each row version means it will only create a timestamp data type in the database if the data type is a byte array, right? But in this case, instead of a byte array, you can make any property as a concurrency column. And for that purpose, you need to use each concurrency. You are having the first name, which is a string type. You want to make that concurrency column? Yes, you can make this. But that is not possible using row version. Row version means the data type should be byte array. We have already discussed, but this is the additional things which is available using the Fluent API. Is optional. It configures the property to be optional, has parameter name. It configures the name of the parameter used in the storage procedure for the property, right? Has a database generated option. If you remember, if we are creating the primary key on an integer column, right, by default it will create that by default it will mark that column in the database as identity, right? And for the identity column, we do not need to provide the value explicitly. But what is your requirement? You want to make the column as a primary column, but you don't want to make that column as a identity column. For that purpose, you have to use has database generated option method. Has column order. If you want to set the column order, column type, and column name. And this max length and precision means what? If you want to set the length of the property, right? There is no mean length, but has max length means if you want to set the length of a column, right, then you have to use has length and has precision. For the decimal type, right, if you remember, we have scale and precision value, right? By default 18, right? And if you want to change that precision and scale value of a decimal type property, then you have to use this has precision. Each fixed length and each variable length. If you remember, in database we are having two different types of string variable, character variable. One is char, another is nchar or varchar or nvarchar, right? So what it basically means, if you want to make a column as a fixed length column, or if you want to make the column as a variable length column, then for that purpose you have to use each fixed length method and each variable length methods, right? String properties are variable length by default, right? So we'll discuss everything with some examples, right? Let us start the discussion. But also whatever method I am showing here, right, every method we are going to discuss one by one. Clear, guys?
Yes, sir.
Right. So
Yes,
if
sir,
you are
clear.
having some SQL Server knowledge, then you might know the difference between varchar and nvarchar. What is the difference between fixed length data type and variable length data type? So just Google it and you will get more information about the fixed length and variable length data type. There is something called ASCII code, So Unicode characters and non-Unicode characters, right? So just Google it and you will get more information. Let us understand this with one example. Let's create a class called student, right? So let me close this one. So we are having some student entity. Let me remove this one. This is my student entity. You can see this class having few properties: ID, first name, last name, branch, city, state, country, and standard ID. Now I'm going to create another entity called standard. And you can see this is my reference property and this is my collection navigation property. That means it is going to generate one-to-many relationship by default. So again, this class having standard ID, name, description, and so in this case, this is the student plus ID. That means by default, it is going to be the primary key. And in this case, this property is going to be the primary key by default. Next, you should have the database configurations. You can see this is my connection string, and my connection string name is my connection string, and the database what it is going to create it is EF code first DB, right? Now configure the default schema using Entity Framework API, right? As I mentioned, how we are going to configure the default schema. Now to configure the default schema, okay, let me first show you the default schema, right? So in this case, if you see, right? So in this case, if you see, this is my constructor connection string I have provided. I have set the database initializer at drop create a database always. That means what is every time I run the application, it will drop the database and create the database. And this is the on model creating method that you need to override. And this is the property. This is the model builder. You can say object or a DB model builder class, and this is nothing but your Fluent API. So how you are going to use this model builder, right? So using the model builder and using the entity, right? Using this is the instance, and on this instance there is a method called entity, right? If you go to the definition of this method, go to the definition, right? So you can see entity, and this is a method, and this method belongs to this model builder class, right? So on this entity, you have to provide the class, right? Which entity you for which entity you want to provide the configurations. No, I want to provide the configuration for student entity. So on this entity, it's a generic method, right? So it's a generic method means while calling this method, you have to specify the entity name or the class, right? For which you want to provide the configurations which needs to be followed by entity framework. I want to provide I want to configure student entity. I want to configure the standard entity, and this, most of the time you will see these things, right? So these things means for which entity you want to provide the configurations. As of now, forget this two table method, but for now, just remember two table method means it is going to create the table with the specified, right? Okay, I will explain this two table method later, but now I'm just explaining the default schema. So in this case, as I have not specified any schema information, right? So you can see by default, the database table is going to be created with the schema DBO, right? So with the schema DBO, what is the two table method use? I will tell later, but for now, just remember, if I have not used this two table, then by default, the table is going to be created with the name students, right? And standard, because this DB set property name. But once you specify the table name, right, then whatever the table name you provide, that will get the highest priority. So now the entity framework is going to create the table name as student info and standard info instead of students and a standard. But these two tables are going to be created with the default schema, in this case, a DBO, right? So let me run the application and show you these things. So before creating the database, right, the on model creating method is going to be executed. And once that method executed, okay, I need to open SSMS. So what is the schema? Is this the database students? No, this is not the database. This is also not the database. Right. So let me run. I'm getting some error. No. Okay. Hmm. See, you can see the standard info and student info tables are created with the schema DBO. Understand, guys?
Yeah. Yeah.
Right. Now what is my requirement? I don't want to go with this default schema. Right. Now my intention is I want to configure the schema, default schema as what I can say. I want to configure the default schema as admin. I don't want to configure the default schema as DBO. Then how you can do this? So for this, what you need to do is you need to use the has default schema method. Right now, what I need to do is, if you remember, model builder, right? And this model builder, if you remember, this is not entity or this is not a property. This is a model wide configuration, right? If you remember from the beginning, I have told you three things: model wide configuration, entity configuration, property configuration. While you are doing the entity configuration, you need to specify the entity name. And for property configuration, again, also you need to provide the entity name and then property configuration, right? But for model, this is not specific to any entity. So here you do not need to specify the entity dot entity student like this. Directly you can call this as default schema. And here I have provided the schema as admin, right? Now, once I provided this schema as admin, and when I run this application, then you will see that instead of student and standard info, right? These two tables are going to be created with the schema as admin. Right now, refresh the database. See, admin is created or not? Right now what is as I mentioned, if you want, you can also specify a default schema. Right now, you want to provide this schema as ABC, right? I want to provide the schema as ABC for this one. Is this possible? Yes. You have to use the other overloaded version of the two table method, which is taking the schema name, right? You can see this is the other overloaded version, which is schema name, right? Now, this student info method is going to be created with the schema admin, not DBO. See, by default, if you do not have this method, then it is going to created as a DBO and it will be created as ABC. But as you specify the default schema as admin, now if you have not specified the schema, then it is going to be admin, not a DBO. And in this case, whatever explicitly you specify, that will get the highest priority over the default schema, right? Now, if you run the application, then you will see that the other table is going to be created with ABC schema, while the student info is going to be created with the admin schema. You can see this is ABC and these two are going to be created with admin schema. So if you want to provide the default schema, then you have to use the has default schema method, and you need to specify the schema that you want to be the default for all of your entities, right? For all of your database table. If you want, then you can also specify a default schema by using the other overloaded version of the two table method. Clear, guys?
Yes.
Right. Next, map entity to table using Fluent API. So this is the default schema we have done. So map entity to table using Fluent API in entity. By default, the entity framework code first approach will create the tables in the database with the name of DB set properties on the context class. For example, if you modify the context class like this, right? Right. So for example, if you modify the context class like this, right? So in this case, by default, right? In this case, by default, the table name is going to be students and standards. Yes or no? Because the DB set properties are students and standard, right? If you run the application, then you will see that the table name is not going to be standard info and student info. Rather, it is going to be student and standards, right? What exactly it means? It means by default, whatever the property name, you can see standards and students, right? So whatever the property name that are going to be created, students and standards. Clear? Now, in this case, the entity framework will create two tables with the name as students and the DB set properties are these. We can override this default configuration using data annotation attribute and Fluent API. We have already discussed how to provide a default name for the database table using data annotation attribute. Now let us see how we can provide a default name, a different name, or how we can override the default convention which is followed by entity framework, right? We have already discussed there are two methods. One is two table, another one is there are two overloaded version of the two table method. One is taking the table name as a parameter, another one is taking the table name and the database schema name as a parameter. So using these two tables, we can provide a different name other than different name for the database table. So how we are going to do this? So we need to override the on model creating method, right? And then we need to specify the table name by using the two table property, right? Let me right. So you can see a map entity to table. So in this case, we are as we are mapping one entity, so you have to specify the entity information. What entity you want to map? I want to map the student entity, so I have to specify the student entity. And then you want to map the student entity to which table? I want to map the student entity to the student info table. So you have to provide a two table method, and to this method you have to provide this information. I want to map the standard entity. So yes, then you have to provide the standard in class name within this entity method. This is the generic method. And I want to map this entity to this database table. So in this case, the standard entity will be mapped to standard info database table. But in this case, by default, in this case, the schema is going to be DBO. And in this case, the schema is going to be admin. And if you want to provide the default schema as admin, then you have to use this one as default schema. And in this case, you have to provide the schema as so anything, right? So if you want to provide the default schema as ABC, then in this case, this table student info will be created with the schema ABC. And in this case, it is going to created with the schema admin. But if I remove this statement, then by default, it is going to created with the schema DBO, and this table is going to be created with the schema admin. Let me delete this table. Right. Let me run the application once more. Now refresh the database. Right? So you can see standard info and a student info. So this is how you can map the entity to the database table, right? You can see standard info and student info. How to map one entity to multiple tables in entity framework, right? Suppose you are having a big class, right? One class having 10 properties or 20 properties, right? In that case, how you can map that particular entity to two different database tables? To do so, if you want to map one entity to multiple database tables, then we need to use the map method. The map method provides some advanced configurations, and that configuration will give the information how the entity will be mapped to database table, right? So for that, what we need to do is, right? Let me change these things. Sure. Okay, let me change. So basically, you can see I'm having two entities. One is student and another one is standard, right? If you see student entity, this entity having some student ID, first name, last name, branch, city, state, country, and standard. The point that you need to remember while you are going for entity splitting means I'm splitting the entity into two different tables. Then in the case of entity splitting, you cannot specify the reference type property. You can only specify these properties, right? So now my requirement is I want to put these four properties one table and these three properties, right, along with the student ID in another table. By default, so guys, the point that you need to remember, by default, the primary key column is available in both the database table, right? If you specify the student ID property or not, that doesn't matter. That is going to be created as the primary key column in both the database table. So in one database table, I want to include this information. In another database table, I want to include this information, right? That means now I'm going, give me 1 minute, guys. That means, guys, I want now entity splitting, right? So how I can do this? And to do this, we need to use the map method. And how we are going to use the map method, let's see. So first of all, you need to specify the entity because this is not model wide. This is entity splitting. Which entity you want to split? I want to split student entity. So to this entity method, you need to specify the student entity. Then which method I want to use? I want to use map method. I want to split this entity into two different database tables. So I'm using this map method two times. Now, if you want to split the entity into three different database tables, then again another map method you need to use, right? And inside this map method, right, of these entities, what are the property you want to include into the student info table? I want to include student ID, first name, last name, and the branch property. And by taking these four properties, I want these four properties to be mapped to the student info table. Now, so again, now other property, city, state, country, I'm fetching these four properties and I'm putting these four properties into the student address table, right? So whatever the properties you want to include inside the student info table, you have to specify using the anonymous object and using this lambda expressions. And then you have to specify the table name on which these properties are going to be stored, right? In this case, student info database table will be created based on the student ID, first name, last name, and branch table. And student address table is going to be created based on the student ID, city, state, and a country properties. And this standard info, this is the normal table. So if you want to provide a different name, then you can provide. If you don't provide this statement, then by default the table is going to be created with the name standards. Now what will happen? Now what will happen means, now whenever I'm entering one student, that student information is going to be stored in two different tables. Some of the information like student ID, first name, last name, branch will be stored inside the student info. And again, the same student ID, city, state, country is going to be stored inside the student address database table, right? Now, okay. So let me go to this first name, last name, city, or city, country, right? City, country, right? So these are the informations, right? Now I'm going to run the application. I run the application. Right, student added. Now if you go to the database table, right, then you can see two tables, student info is there, student address is there. Now if you expand the student info, then you will see one record which will contain the student. This is standard, not student. So if you expand the student info, you will see one record. What is the record? First name and the last name, right? So we have not provided the branch information. And if you expand the student address, then you will see the student ID, city, state, and country. Whatever information we have provided, those informations are stored here, right? And student ID is going to be created by the here we have specified, even though if we do not specify, right, let me delete this one. Right, so in this case, if you check the context class, we have specified the student ID. Let me remove the student ID because this is the primary key. And if you remove the primary key, right, now run the application, then also you will see that both the database table are going to be created with the primary key. Yes. Now refresh the database. Now go to the tables, student address. See student ID is there and student info. Student ID is also there. That means the primary key column you can specify here or you can specify here in both the places. If you do not specify, that is also not an issue. Now let me do one more change. Here last name is there. I just copy this one and paste it here. What happens? Right, now let me run the application. So what it's saying, properties for type student can only be mapped once. The non-key property last name is mapped more than once. So what exactly it means? It's saying that the key column you can map to twice. If you do not map, then also it is not an issue. But not key column you cannot map to twice. In this case, you can see last name already mapped. Then you cannot map that last name. You cannot map that last name more than once, right? So this is the point that you need to remember. Key column, key property, you can map to twice, but non-key property, you cannot map to twice. It should be mapped only once. Once you mapped, if you try to map to one more time to a different table, then you will get the compile, you will get this runtime error. Is that clear, guys? Clear?
Yes. So one question.
Sure.
What could be the reason of splitting an entity into two?
Right. See, splitting basically, see, if you do not want to create, right, if you know database normalization and all those things, right, then if we are creating some student table, student address table, student basic information, right, so forget about the student employee address, employee some sensitive information, right? So from a database normalization point of view, we should not store all the information in a single table, right? What we generally do is we are making some kind of relationship. We are storing the student, we are storing the data into multiple tables to remove the redundancy, to remove the duplicacy, right? And for that purpose, we are just splitting the database table into multiple tables. The same concept here, but for example, in your application, you want only one model class to store all the data, and but when in the database side, you want to store the data into different tables. Then for that purpose, you need to split the table you need to split the entity into different table. You know what is database normalization and all those things.
I have some ideas. Yeah.
Yeah, just try to understand what is the advantages of database normalization. I can store all the information in a single table. Then why I'm splitting the table into multiple tables in the database, right? Why I'm creating a product info, product table, product I mean product sale quantity, right? Different. Why I'm creating different tables, and why I'm uh, um, establishing the relationship between the tables. If I'm not establishing, then what is the problem, right? Just try to understand. And if you want to learn what is exactly, right, so I think I have written one good article on database normalization database, right? So I'm just sharing this link in the chat. Just go through the link and you will understand the advantages of a table splitting. Got it? So what is the advantages, right? So redundant, duplicated data, incorrect, bad data. Why I'm getting this kind of issues, and what is how you can resolve this using database normalization, right? You will get a good idea. Clear, guys?
Yes, sir.
Right? When you add one student entity using the context class, then the data will be stored in the above two database table based on the properties. Right? Using the map method, we cannot map the reference type properties, right? So in this case, say if you see the student entity, there is a property called reference type. You cannot map that, right? If you try to map, then you will get some kind of a error, right? So if you map, then you will get the error. Like this, you cannot map the non-key properties in more than once, right? See, standard understood cannot, because it has been exclude model, right? So you cannot include the reference type, and if you try, then you will get this error. Clear, guys? How to map one table to multiple, how to map one entity to multiple tables, and what are the things you can do, what are the things you cannot do. Is that clear?
Yes, sir.
Okay. So we have discussed two things. We have discussed database schema, how you can set. We have discussed how you can specify a different table name, and how you can specify different. I mean, how you can split the how you can split one entity into multiple database tables. Now the important thing, right? This is not that important, because normally for one entity we are creating one database table in the database. In very rare cases, you need to split the table, right? But what is important, that is what we are going to discuss. Property configurations using Fluent API, right? The Entity Framework Fluent API can also be used to configure properties of an entity to map with the database column in the database. So whenever I'm saying property configurations, that means it is the configuration between your properties with the database column in the database. So using Fluent API, we can change the corresponding column name. Suppose one property name is first name in the database, you want to create the column as F name. Suppose the data suppose the data type is string, so which is by default is going to be created in varchar, and in the database you want to create as a varchar. Suppose you want to change the length of the database column in the database, right? Order of the column in the database. If you want to make a column as null or not null in the database, you want to configure the primary key, foreign key, concurrency column in the database, right? Every information, that is what you want to configure, right? We have already discussed using data annotation. The same all information, so same all configurations we can also do using Fluent API, right? So let's see how we can do this. For this, we are going to use these two student classes. Let me modify the classes because these things we are going to use. So as per our requirement, we need to modify the student and standard entities. So this is student entity and this is standard entity. right? So we have created the student class. You can see there is no standard plus ID property in the standard table. And here you can see there is no ID or student ID property in this student table. This is the point that you need to remember. Configuring primary key and composite primary key using Fluent API. Okay, so before proceeding further, just tell me what is the default convention for the primary key by Entity Framework? With what name it will look for the entity?
Key.
Exactly, key name. But what should be the name?
Class name same as.
No,
ID.
ID or
The name.
entity name plus ID, right? For the student, the entity framework will look for the ID property within this class or student ID property within this class, right? But tell me, is there any such kind of properties available in within the student class?
No,
No.
sir.
And in any such kind of properties or property available within the standard class?
No.
No. That means what? Now, if you try to run the application, okay, let me remove these things. Now, if you try to run the application, then what will happen? Let's run the application and see what will happen. Why I'm getting this error? Okay. Remove this. So definitely it is going to throw me one error and saying model validation exception, right? What exception it is saying? Okay. Okay, for the standard entity, standard has no key defined. It define the key for this entity type. For student entity type, student has no key defined. Define the key for this entity. So what it means? It means it is complaining that you are going to create two database table, and for those two database table, no key is defined in the entity class. Please define the key and then execute the application. And now, what is our requirement? Our requirement, we do not want to make the ID or student ID as the primary key. We want to make this registration number as the primary key, and we want to make the standard key as the primary key. How we can do this? And this is where the hash key method will come into the picture, right? So this is where the hash key method will come into the picture. So how we are going to use this? Let me show you, right? So you can see for the student entity, I want to set the student registration number as the primary key. Then what I need to do is I want to use the hash key method, and to this method using the lambda expression, you need to specify the property name. Which property you want to make the primary key for the student entity. I want to make this registration number, student registration number as the primary key. So I have specified this. For the standard entity, I want to make the standard key as the primary key. Then I have to specify this using the lambda expression and using the hash key method. So with this, with the above changes in place, now if you run the application, the student database table, right? What should be the table name? Students, because it's we have not specified the two table methods, so it is going to be students and it is going to be standards. If you want to use two table, then you can also use the two table here, right? And two table, and you want to make this as student info, that is fine. I am getting this error.
It is string.
No, it's a string, right? You can also specify like this, right? But that is what we have already discussed, and this is possible because you just need to call the method and that's it. So now with the above changes in place, you will see that the student info table is going to be created with student registration number as the primary key. And in this case, what should be the table name for the standard? The table name is going to be the deficient property name. What is the name? Standards. And the table is going to be created with the standard key as the primary key, right? And if you want to provide a default schema, like by default, the schema is going to be DBO, and I want to create this schema with the admin. So you can also specify like this. Clear, guys? Any question? Any doubt or any question from anyone?
No question, sir.
Okay, now let me run the application.
No, sir.
Yeah. So let me run the application and show you the things. Yes, student added. Now refresh the database. Right now, go to the table. So you can see student info. What should be the table name? Not student. It's student info with the schema admin. And here dbo.standards. Now, if you expand the columns, you will see this is my primary key PK. PK means it's the primary key. And if you go to the standard, then you will see standard key is the primary key. Clear, guys? How to make the primary key? Clear?
Yes, sir.
Yes.
And in this case, the student registration number, right? In this case, the student registration number is going to be created as your identity column, right? So if you expand the script of this student info table, then you will see that student info, right? The student registration number is going to be your identity column. Clear? In this case, also you will see standard key is going to be your primary key column. And that primary key column, right, it is going to be identity. So this is standard key is the primary column, and it is going to be created as the identity column. Why? Because these key are nothing but on integer data type, right? If you see the table, so this is the integer data type and it is the integer data type. So as integer, so it is going to generate the column as identity column in the database. Clear? Clear or any question?
Clear.
Right? Now, switching of identity for numeric primary key column using Fluent API. Now what is our requirement? Our requirement is that we do not want to generate the primary key column for these properties, right? I want to make this I want to make standard key as the primary key column, but without identity. Is that possible? Yes, that is possible. How? Okay, so before that we need to delete, otherwise it will show you that database is in used, right? Let me delete the database, close existing connections, right? So if you want to make any column, right, if you want to switch up the identity for the numeric primary key column, then you need to use has database generated option method, and to this method we need to specify the option as none, right? How we are going to do this? Let me show you. Right? So you can see this is the student key and here I'm making this as student registration number, right? And has key means this will mark this entity as the primary key. Now it will create this registration number property as the primary key column, and by default it will make that primary key column as the identity column. Why? Because it is the data type of this property is integer. Now I want to turn off the identity of this particular column, of this particular, or you can say of this primary key column. How I can do this? So you have to specify the student entity, for which entity you want to provide the property configurations, right? So this student registration number, it is nothing but a property, right? From this student entity, please select this student registration number property, and for this student registration number property, please make the database generated option as none. We have already discussed the different options. So database generated option none means now it will turn off the identity of the student registration number. That means what? Now while generating the database table, it will not include, it will make this column as the primary key column, right? But it will not include the identity for that column, right? Now it is your responsibility. While inserting the data, you have to specify the value explicitly as a developer, right? So now we need to take the responsibility of providing the value. So how to switch up? So for that purpose, first you need to specify the entity name using the entity method. Then you need to fetch the property for which property you want to make the identity of. And then you have to call this has database generated option method. And here you need to specify the option value as not. Now, if you go to the option value, then it is saying that the database does not generate values, right? That means what? Now the database is not going to generate the values for this column. So as a developer, you only need to provide the values while inserting the data, right? So now, okay. So what is the ID value? Student registration number. I'm providing the value as 100, right? So now run the application. Student added. So now refresh the database. This is students, right? Right. So you can see now student registration number is created. Student registration number is your primary key, but this is not the identity column. Clear, guys? Guys,
Yes.
this is how you need to turn off. Any question related to these configurations? Give me 1 minute, guys. Okay. So this is how we need to turn off the identity column while generating the primary key. Now, can we create primary key on string property using Fluent API? So if you remember, while using data annotation attribute, there is a strict rule that you can only make the integer column as the primary key column. But with the Fluent API, this restriction is not there. You can make any data type column as the primary key column, right? So we have already discussed how to make the primary key column using the integer data type. Now I'm going to show you how I can make the primary key column on the string column, right? So to do so, what I'm going to do, I'm using this one. So right now, if you see, using the hash key, I'm specifying the first name as the primary key column, and using the hash key, I'm specifying standard key as the primary key column, right? So this is my string column name and this is my integer column name. But for this integer column name, it will generate the identity column. But while you are making any non-integer column as the primary key column, then in that case, it will not generate the identity column, right? So let me delete the database. Right now, with the above changes in place, so let me run the application. Okay, now if you verify the database, tables, student, generate script. See, here you can see first name as the primary key column and it is not the identity column. And if you go to the standard, then you will see that it is going to be the student standard key as the primary key column. And you can see this is the identity because it is the integer data type. And in this case, this is n marker. So as n marker, it will not generate the identity column. Clear, guys? Guys, is that clear?
Yes, sir.
Right. So now we need to understand how to configure composite primary key. So composite primary key means what? Now, if you want to generate the primary key based on multiple database column, then we need to use the composite primary key. A primary key based on multiple columns is nothing but your composite primary key. And the point that you need to remember is that whenever you are creating the composite primary key, it doesn't matter whether the primary key is created on integer or a string data type, right? It is not going to generate the identity column. So for composite, there is no identity column, right? So let me show you how I can create a composite primary key. The same hash key method, but here we need to specify an anonymous object, right? So in this case, you can see this is a simple object. So here the key is based on a single property. So I can directly specify the lambda expression like this. So here, as I have to mention two different properties, so I need to put those two properties within an anonymous object. So this is nothing but your anonymous object, and within the anonymous object, what are the properties you want to include as part of your composite key, that you need to specify. Here you can see I'm specifying the student registration number and student roll number, right? And in this case, once you run the application, then you will see that this is going to be generated as the composite primary key. Now run the application. Now, if you now refresh the database, why I'm deleting the database again and again, and the reason is once I open the data in the query window, then I cannot delete by using Entity Framework because the database is currently in use. This is the reason why I'm deleting the data again and again. And if you are doing the same, then you also need to do the same thing. right? So you can see one query window is open, which is targeting this EF code first demo DB. So you can do this, right? So you can see the primary key clustered index is created on two different columns. One is student registration number and another one is student roll number. And in this case, you can see without identity column. Great, understand? Is that clear, guys?
Yes, sir.
So basically, if you are creating a primary key on an integer column, then that column is going to be created as an identity column. If you want to turn up identity for that column, then you can do this. It is also possible to create the primary key on a non-integer column like string column. In that case, no identity column is going to be generated. Composite primary key column is also possible. In that case, no identity column is going to be generated. It doesn't matter whether the two key columns which are involved is integer type or other than integer type, no matter, but no identity column. Clear? Okay. Now, configure column name, type, and order using Entity Framework Fluent API, right? So if you remember, by default, what should be the column name in the database? The database, the property name is nothing but the column name in the database. By default, what is the data type of the property is going to be same as the data type in the database, and order is also same. So by default, the default property name, type, and order is going to be the same as the database column name, type, and order, right? And we have already discussed we can overcome this default convention, right? We can overcome the default name, type, and order using two approaches. One is data annotation attribute, another one is Fluent API. So we have already discussed data annotation attributes. Now we are going to discuss how we can overcome the default column name, type, and order conventions, which is followed by Entity Framework using the Fluent API. And for this, the Fluent API provides us three different methods. One is hash column order, one is hash column type, and another one is hash column name. So using this hash column order, you can configure the column order. Using hash column type, you can configure the data type of the column, and using hash column name, you can provide a different name rather than the property name, which is going to be generated in the database, right? Let us understand this with an example, right? Let me first modify the student entity. So what I'm doing, I'm making the student ID. So this is going to be my primary key by default. I'm making this first name, last name, and I'm creating the student entity with first name, last name, and a date of birth properties, right? For properties. Now, what I want to do is, right? So what I'm doing here, I'm going to provide, right? So if you see the student entity, this date of birth property, the data type is date time, the name is date of birth, and the order is 0, 1, 2, 3. So now my requirement is I want to provide, right, for the student property, I want to provide the column name, database column name as a DOP. I want to provide the data type as date time 2, and I want to provide the column order as 2. So these three informations I want to override for this particular property. How I can do this? For that, we need to override the student first. First of all, you need to specify the entity name. What entity? The entity name is student. Then you need to provide the property name. What property information you want to update? I want to override the date of birth property. What are the information you want to override? You want to override the column name? Yes. So please make use of this as column name method and provide the updated name. What should be the column order? Column order is going to be 2. By default, data type is date time. So I want to now make the data type as date time 2. Yes, that is also possible. So with these tenses, what should we expect? We expect the date of birth property should map to DOB column in the database. The column order should be 2 and the data type should be date time, right? Now, right, date time 2. Now, what I'm going to do, right? So now I'm running the application. Okay, now go to the database, refresh the database. You can see the database table and you can see student. See DOB, student ID, first name, last name. But the thing that you need to remember, DOB, it is created as a date time 2. But the problem is the database column order. We expect the column order to be 2, but it is coming in the position of 0. It is indexed. Indexed means it is started from 0. So the column order is not working. Apart from column order, so whatever the column name we specify, whatever the data type we specify, that is working as expected, but not the column order. Why? If you remember in data annotation attribute, we have already discussed this. If you want to specify the column order, then you have to specify the column order for all the properties. Otherwise, it is not going to be work. Yes or no? Guys? If you are applying the order data annotation attribute, then you have to apply that attribute to all the properties of the entity. Otherwise, it is not going to work. The same concept is also applicable here. Here, the column has column name method is working as expected. Has column or type is also working as expected, but column order is not working because if you remember, if you go to the context class, you can see the column order we have only applied to this data part properties, but we have not applied to other properties. And this is the reason why it is not working, right? Now, if you want to make sure that this property should work, then what you need to do is you need to provide the has column order at method on all the properties. So you can see now the order is 2, this is order 0, this is order 1, and this is order 3. So it should be the first column student ID, second is first name, third is DOP, and the last one is last name. With this change, right now run the application. Student added, right? Now refresh the database, expand the tables, and expand the columns. Now student ID first name, DOP, and a last name. Is that clear? Guys?
Yes, sir, clear.
Okay. Configure not and not null columns using Entity Framework Fluent API, right? So okay, in .NET, right? In .NET. So if you are creating some primitive data types, if you are having some primitive data types like integer, decimal, right? So are they are going to hold null value? Right? Just tell me, if you are creating a primitive data type like integer, decimal, etc., does they hold null value?
No, sir. No.
Does they hold null? The answer is no. Right? Now, if you want to store null value, then what you need to do?
Yeah. Nullable types.
So you have to write
Question mark.
mark, or you can write nullable. Yes or no? Then does they hold null value?
Yes.
Yes. Clear or not? Okay. if you are having some reference data type, like string, like student, etc., right? Does they hold null? Does they hold null?
Yes.
Right? So this is the things, right? Forget about these things. By default, primitive data types such as integer, decimal, they do not hold the null value. And by default, reference data type, they hold the null, right? Now, so for this primitive data type, right, the database column, what the entity framework is created is going to be not null, not null. And for the reference data type, whatever the database column created in the database, right, they are going to be what? They are going to be null, right? For example, if you look at the student entity, so student ID is integer, first name, last name is string data type, right? Now, if you go to the database, student as integer, integer means it is not null or null. What it is showing?
Not null.
Not null. For first name DOB and last name, the data type is going to be right. For first name, it is null. Why? First name is a reference type. What the reference type means? If you go to the database, so student ID is integer. Integer means it's a primitive data type. How you can say that it's a primitive data type? Because the type is struct. For first name, it is a string. String is a reference data type. Why? Now, if you go to the definition, you will see that it's a class, right? And for date time, if you go to the definition, then you will see that it's a struct. Struct means what? It's a primitive data type. So for student ID and the date of birth, it is going to create the column as not null, while for the first name and last name properties, it will make the database column as null, right? So you can see student ID not null, DOP not null, because they are primitive data type. They cannot hold the null value. This is the reason why they mark this column as not null. First name and last name, they are reference type. Reference type means it is going to be created as null. Clear? This is the default convention. Is that clear? When the entity framework is going to create the property as null, and when the entity framework is going to create the property as not null. Null means it's a reference type. Not null means it's a primitive data type. Clear?
Yes, sir.
Right. Now, what is our requirement? Now, the requirement is that, yes, from the data, from the entity model point of view, that is fine. But now, it is also possible that I can directly insert data into this data table using the SQL Server Management Studio, right? So what is my requirement? My requirement is that I do not want to store null value on the first name column. Try to understand. I do not want to store null value on the first name column. I can store null value on the DOB column. That means what? The default convention is not going to work, or it is going to work. If you want to store, if you do not want to store null value on the first name column, then whatever the database table it is created, it is not going to work, because it will accept null value. And if you want to store null value on the DOB column, then by default, this is not going to work, because it is created with the not null constant. That means what? It means we need to override this default conventions, right? By default, if it's a primitive data type, it is going to be not null. And if we want to make that primitive data type as optional, right, then you have to use the each optional method. By default, the string or the reference type properties are going to be not going to be nullable type in the database. If you want to make that column, right, in the database as a not null column, then you have to use the is required attribute, right? So is required method. So basically we are having two methods. One is required and another one is is optional, right? So by using this is required and is optional method of Fluent API, we can specify whether a property is going to be not null or null in the data. Right now, let me modify these things, right? So you can see for the first name property, I want to make this as is required, right? And here you can see in the student entity, this first name, last name are string type, so they can hold the null value, and student ID and student registration number are integer type, so they cannot hold the null value. And I want to make this as a primary key, so primary key means it is not null. But now the student registration number, I want to store null value on the student registration number. You have two options. What are the options? You can store like this. If you create like this, that is going to be created a nullable type. If you are another option like this, in this case also it is going to create the column as a nullable column, right? And the other option, that is what available is, I don't want to make the not null or all these things here. Rather, I can configure. What I can configure? I can configure this property as each optional. Right now, in the database, first name column will be created with the not null constant, and a registration number, student registration number column will be created with the null constant, right? So with the above changes in place, now run the application. Student added. Now refresh the database. You can see first name, now it is not null, last name is null. Why it is null? Because we have not applied the each required method. Student registration number, you can see this is now null. Why? Because we have applied the each optional method. Clear, guys?
Yes, sir.
Right. So this is how you can make the null or not null column in the data. So configure column size using Entity Framework API, right? It is also possible to set the column size using Entity Framework Fluent API. By default, for string or byte array properties, right? If you are having some string or byte array, then by default the column size is going to be n varchar of max for string properties and n binary max for byte array property, right? So you can see n varchar of max for the string properties, and for byte array it is going to be var binary of max. So this is the default, and for decimal properties the default size is going to be 18,2. So these are the default size which is uh, used when the database is created by the entity framework. Right now, what is our requirement? We want to override the requirement. Now we want to override the default convention. I want to set the maximum length. So here I do not want to max. I want to set the column length as 100 character, column length as 200 character, right? Or while byte array, I want to provide an explicitly value for that range, right? That is also possible. And for that, what we need to do, we need to use the has max length property, right? And for decimal, by default it is 18,2, and now you know that the maximum value for the precision is 7 and for the scale is 2. Then why I'm going to use 18,2? I want to use 7,2 or 8,2, right? For the floating, for the decimal column data type, right? Then what you need to do? Then you need to use the has precision method, right? And using this precision method, you need to specify the precision and scale value as per your requirement. And each fixed length data type, it configures the property to be fixed length. Use has max length to set the length of the property is fixed length, right? And each variable length means it configures the property to be variable length. String properties are variable length by default, right? So let us understand this with one example. So this is my student entity, right? This is my student entity. You can see first name, last name are string type, height is decimal type, weight is floating type, photo is byte array type, right? So with these changes right now, let us run the application and let us see the default first. Why I'm getting this error? Student doesn't contain student registration. No. Okay, let me remove this. Let me first show you the default conventions. What is the default size of each data type? For integer data type, there is no size. For a character or for the string data type, there is size. Right now, let me refresh these things. Right, column. So you can see first name, last name. They are variable length. Variable length means n bharkar. Fixed length means bharkar. What is the difference between fixed length and variable length? Can anybody tell me? From the database point of view, I'm not, this is from the database point of view. Suppose I have declared 100, I have declared 10. I have declared 10, right? I have stored one value hello. I have stored one value hello. In this case, the size is going to be 5 characters, right? So 5 bytes, 5 into 2, 10 bytes. If character taking 2 bytes, then it will be like a 10 bytes. In this case, what will be the size? Size is going to be 20 bytes, right? Sorry, this is wrong. This is variable length. And this is fixed length, right? So variable length means based on the value, the length will be varied. So even though you have set the length as 10, right, maximum 10 characters. So if a particular character takes 2 bytes, then if you are storing this value, then it is going to take 10 bytes in the memory, right? And in the case of fixed length, even though you are storing a value of 5 characters, then also it is going to allocate 20 bytes in the memory because the length is fixed. In this case, the length is vary. Vary means at runtime, right? At runtime, it will check each character and then it will decide the size, and then accordingly it will allocate the size. In this case, at runtime, it is not going to decide the size. How many characters? What should be the size? These things are not going to happen in this case. So in this case, directly it will allocate 20 bytes of memory. Then now you just tell me which one is good. Guys,
Fixed length is good.
fixed length is good. How? So in this case, how much memory is allocated to store this value? Guys,
Yes, sir.
which one is good? Which one is good, fixed length or variable length?
Variable length,
How?
because in variable length only 10 bytes is allocated, whereas fixed length 20 bytes, right?
Right, but nothing is free in this world. If you are using variable length, right, then it will take some time to calculate the length. What is the number of a character? How much length I need to allocate to store this value? This will take some time or not?
Yes.
Then in this case, is that time is that calculation is done here?
No.
Then which one is good? So basically, you need to decide. So basically, whether you need to use the variable length or fixed length, that basically depend on the data you are going to store. If you know, right, if you know I'm having one column, right, I'm having one column, let's say some column, I'm having some column in the database, and I know this column value always is going to be of 10 characters, always, right? If I'm having some column and if I know this this column going to store some value that is of some fixed length characters, then in that case you need to go with the fixed length data type. Why? Because you know the length is 10 bytes, so I need to create one. You know the characters that you are going to store, the data that you are going to store is about 10 characters. Then I can create a column of size of the length 10, right? And I can make that column as a fixed length column with the size 10. So each time it is not going to calculate the number of a character and allocate the size. Randomly it is going to store the character. But if some other column, right? So in this case, so which one is better? In this case, you need to go with the fixed column, right? But this is some column 1. Right now I have another column. Characters vary. Characters varies. So you do not know in advance how many characters I am going to store in the particular database column. If you do not know the column length in advance, that is what is the length of the column that we are going to store, then in that case, you need to go with variable length column. Why? In this case, you need to go with variable length column because you do not know the length of the column in advance. If you create one fixed length column with 100 character with size 100, and if you are going to store 2 characters, then there is unnecessary 98 space is unused, right, which is going to degrade the performance of your application. But if you know that 10 characters is always going to be stored in the database column, then you need to use the fixed length data type. What are the fixed length data type? If you know car, right, varchar, these are your fixed length data type. And what are the variable length data type? The variable length data types are nvarchar, nchar, and nvarchar. Again, what is the difference between char and nchar, nvarchar? Now, if you want to store, right, if you want to store Unicode characters, then you need to use varchar or nvarchar. If you do not want to store Unicode character, so in that case, you need to use char and nchar. If you are using char, then the size of each character is going to be 1 byte. And if you are using varchar, the size of each data type is going to be 2 byte. And in this case, the size is going to be 1 byte. And in this case, the size is going to be 2 byte. Right? And in this case, it will basically going to store your Unicode. Unicode means what? Now, universal code, right? If you want to store some English language, Odia language, Hindi language, Spanish, French, right? Any type of data you want to store, then if you want to go with the fixed length data type, you have to use this one. If you want to go with the variable length data type, then you need to use varchar. And if you do not want to store Unicode, then if you want to store only ASCII code values, then you need to go with the char or nchar. And if you know the size of the data, and that is going to be fixed for all the always, the length is always going to be same, then you should always go with fixed length. And in the length is varies, right? And in that case, you need to go with the variable length column. And by default in .NET, if you are creating a string column for the string properties, the data type is always going to be nvarchar. Right? Clear? So for string, the data type is always going to be nvarchar. Right? So you can see we are having first name and last name string column. The data type is going to be nvarchar. I will show you how to make this column as fixed length and how to make by default they are variable length. And if you want to make a particular column as fixed length, then you have to use the fixed length method. And if you want to make a column as variable length, you have to use this each variable length method. But the thing is that by default, string properties are variable length. So no need to call this method. But if you call, then there is no issue, right? And once you call this each fixed length method, then what will happen? Once you call the each fixed length method, then instead of nvarchar, it will convert the data type to varchar, or if it will convert the nchar to character, right? And this we have already discussed. If you want to set the size of the column, you have to use a hash max length. And if you want to set the precision and scale value of a decimal data type, then you have to use this. Clear, guys? Okay. So once we see the example, then you will understand these things better. Right. So let me. Right. So first of all, set first name column size to 50. By default, the data type as nvarchar, that is variable length. So in this case, first length, its data type is going to be nvarchar of 50. So in this case, what will happen? The data type is going to be nvarchar of 50 variable length. Optionally, you can also call the each variable length method to make the data type as nvarchar, right? So if you call this method, right? If you call this method, then also it is going to create the variable as nvarchar of 50, right? Because this is optional, because by default string properties are a variable length only. So you have these two options. If you want this one, that is fine. And let me comment this one. Let me use this one, right? Set last name column size to 50 and change data type to n character. Each fixed length change data type from nvarchar to n character, right? So variable character to okay. So here I have one small mistake, and this is nothing but n character. So this is nothing but this is n character, and this is n. This is varchar and n varchar. So I have one small mistake. So for fixed length, if you want to store the data type, non-Unicode data type, the data type is character. For Unicode, the data type is n character. And for variable length, the data type is varchar for non-Unicode, and for Unicode, the data type is going to be n varchar. This is the small mistake. So this is the thing, right? So in this case, by default, the data type is going to be nvarchar of 50. Means what? Now the data type length is going to be variable, and it is going to store Unicode characters. In this case, once I make this data type as each fixed length, so what you will do, you will convert this from nvarchar to n character, right? N character. So n character means what? Now it means it is a fixed length data type, and it is going to store Unicode character also. So the data type for this column is going to be n character of clear. So n character of 50. So you can see n character as it is going to store Unicode. So n character of 50, and here n varchar of in this case it is going to be by default n varchar. So if you want to set the data type, so we have already discussed. If you want to set a different, if you want to set a character, right, n character, we have already discussed hash column data type method in the preview. Already we have discussed that, right? So now we have set this data type as a variable data type. This is going to be your variable data type, and this is going to be your fixed length data type. Variable data type, and this is going to be your fixed data type, right? And now you want to use each fixed length we have discussed, each variable length we have discussed, hash max length we have discussed. So what is remaining? Remaining is a hash precision, right? So hash precision, if you see the height property, what is the height property value? Decimal 18,2, right? For the float, you do not need to specify. This is real. There is no need to specify the size. And for integer, no need to specify the size. But for decimal, there is some precision and scale value. And by default, it is 18,2. Now, what is our requirement? I want to set the value as 78,2. So as precision, you have to use the first, you need to specify the entity, then you need to specify the property, and then whatever the configuration you want to specify for that respective property of that respective entity, then you need to call the method like this, right? Has precision 18,2. So with these changes, what will happen? First name will be created as n marker of 50, and this is going to be your variable data type. Last name is going to be created as n character of 50. It is going to be fixed data type, and this is going to be created as the data type as decimal of, right? It is going to be created as decimal of 18,2. This is going to be 8,8,2, not 18. It is going to be 8. So you can see this is decimal 8,2. Right now, run the application. Student added. Now refresh the database, right? So column size, so you can see first name n marker of 50. That so whenever you are saying var means it's a variable data type, and if you are not seeing that var keyword in the data type means it's a fixed data type. This is the simplest way to remember whether it is a variable data type or fixed length data type. Last name, you can see var is not there, n character of 50 means it's a fixed length data type, right? And height, you can see decimal 8,2. Clear, guys? Guys,
Yes, sir.
so these are the things that you need to remember. So concurrency, we have already discussed what is the importance of a concurrency column, right? In data annotation, we have already discussed what is the use of a concurrency. In that case, we have discussed we have to create one byte array type of a property, and then we have to decorate that byte array type of a property with the timestamp attribute. And once we decorate that timestamp attribute, then it will create a timestamp column in the database, and that column is going to be used while we are updating the data or while we are deleting the data, right? And why it is used to avoid the concurrency issues, right? We have taken one example, and I have already shown you how this is worked, right? Now the same thing is also available here, right? So here, but the point that you need to remember is, in the case of data annotation attribute, you can only use a byte array property to handle the concurrency issues. But with the Fluent API, right, we can handle that concurrency issues using byte array property as well as other string properties, right? So if you are having some string property, then you can use this concurrency token that will make that property, that will make that column as a concurrency column. Even though if you are having some byte array property, you can use this isRowVersion method, and that rowVersion method will make that column as the concurrency column. Let us understand this with one example. Let me first modify the student entity, right? So in the student entity, you can see student ID. This is going to be my primary key. First name and last name, these are two string column, and this is going to be my byte array property, and the name is rowVersion. So previously, if you want to use timestamp, then you can only use timestamp on this byte array property. You cannot use a timestamp on this string properties, right? But now with Fluent API, what I want to do is I want to make this first name as a concurrency column, and this rowVersion also as a concurrency column. Both options are available. Any option you want, you can use. I'm going to show you both the options, right? The point that you need to remember is for string data type, right? For string data type, you need to use each concurrency token, and for byte array, you need to use each rowVersion method, right? So you can see first name, I'm using each concurrency token, and for rowVersion, I'm using this is rowVersion method. And if you go to the rowVersion, then it is going to be a byte array. First name is a string. So if you are working with string data type, you do not want to make any additional column for concurrency check, you can use that here, right? And if you want to use additional, if you do not want to use this string, and if you want to create additional column for concurrency, then you can also use this. Both the options are available. Clear, guys? And you can see for this rowVersion, it is going to create the database table as a timestamp, right? So let me run the application. right? So now if you refresh the student table, then you will see that for the past name, it is going to be used internally as a row version, and for concurrency column, and this row version, it is also going to be your concurrency column, right? So both options are available. Any option you want, you can use for concurrency check. Clear, guys? Guys? Okay. So now the last thing that what we are going to discuss is how to ignore a property mapping, how to ignore a property while mapping to the database table column, and how to ignore a entity while generating the database, right? And for that purpose, we are having the ignore Fluent API method, right? Let me first create the student table. So this is my student entity. I created the student entity with 4 properties: student ID, first name, last name, and a branch. And then I'm going to do some modification. Right. So what modification I'm doing here, you can see I'm ignoring the branch property. Right. So first of all, no need to explain these things, because which entity property you want to configure. I want to configure student entity, that you have to specify. And there is a method called ignore method. And to this ignore method, using the lambda expression, you need to specify the property that is available within the student entity. So here one property is called branch. And now my requirement is I don't want to include this branch property while generating the database table, right? Now, if you go to the student, you can see this branch, but here I'm just ignoring the branch property in property mapping, right? Now run the application, and once you run the application, then you will see that the database table is created, but without the branch column, right? Okay, now refresh the student table, and here you will see that branch column is not there. So if you want to ignore, or if you don't want to include any property, then you need to use this ignore method, right? The next what I'm going to show you is how to ignore an entity while generating the database table, right? So now my requirement is we are having 2 entities, right? You can see we are having one student entity and another standard entity. But if you see here, I'm ignoring the branch property of student entity, but here I'm simply ignoring the simply ignoring the standard entity, right? So model builder, the entity student, ignore branch. So from this student entity, please ignore the branch property while generating the database column. And here what he will do, it will simply ignore the standard entity, even though the standard entity is created as a DB set properties, right? But as we ignore, right? As we ignore the standard entity, so the entity framework will not generate any database table for the standard entity. So in this case, you will see one table with the standard student's name, but you will not find the standard table in the database, right? Run the application. Right. So you can see now, let me refresh. Right. So even though you can see only students here, but you will not find the standard. Why? Because this model builder, that ignore method, it is going to ignore the standard entity. Clear, guys?
Yes, sir.
Right. So that's it for today. Tomorrow we are going to discuss the relationships, right? How to generate the foreign key, how we can implement one-to-one, one-to-many, and many-to-many relationships in entity framework or first approach. Any question from anyone? Okay. Okay. Thank you, guys.
Thank you, sir.
Thank you, sir.
Thank you, sir.